Good number.
Yes, sir. Good morning, sir, and good morning, everyone. My name is Dushyant Singh Rathore, and me and my group is presenting you a PPT on the topic contouring using Q-GIS software, where we have used the Q-GIS software to make contour lines. Now, this PPT is being prepared and presented to you by Dev Bhandari, Dushyant Singh Rathore, Shubham Parikh, Purva Thanki, and Krishna Dimar under the guidance of Professor Dhaval sir. Now, for the further proceedings, I will like Krishna Dhimar to present you a theory on the QGIS and the contour lines.
So hello, myself Krishna Dimmer, and now as our project is on contour, so the first question came in our mind is what is contour line? So basically, first of all, we see generally the definition that a contour line is an imaginary line on the ground joining the points of equal elevation, or we can say that it is the outline, boundary, or border of a figure or a body that defines the shape of the object. हमें डेफिनेशन से तो उतना ज्यादा कुछ पता नहीं लगता है, तो हम फिगर के थ्रू समझने की कोशिश करते हैं कि कॉन्टूर लाइन एग्जैक्टली होता क्या है। तो अब हम फिगर देखते हैं। तो अभी जैसे कि आप फिगर में देख रहे हो, जैसे कि टॉप मोस्ट लेफ्ट साइड जो फिगर है उसमें एक हील बनी हुई है। अब उस हील पे मैं किसी भी एक पॉइंट पे जाता हूँ और उस हील के अराउंड में मूव करता हूँ, तो मुझे कुछ एक सर्कुलर पार्ट टाइप सा दिख रहा होगा। जैसे कि मैं एकदम नीचे वाले पॉइंट पे चला जाऊं हील के, और उसके आसपास में अगर मूव करूं तो जो एकदम बाहर का जो आप सर्कल देख रहे हो नीचे की फिगर में वो बन रहा है। अब मैं हील के कुछ हाइट पे चल जाता हूँ, फिर मैं वापस से उसी हील के आसपास घूमता हूँ, तो मुझे एक दूसरा सर्कल मिलेगा। और ऐसे करते करते मैं थोड़ी थोड़ी हाइट बढ़ाता जाता हूँ, ऊपर जाता हूँ, और मैं गोल गोल घूमता हूँ, तो मुझे कुछ नीचे जो फिगर बन रही है जो हम एक पेज पे बनाते हैं जो बन जाती है। अब इसमें यहाँ पर ये जो लाइंस बन रही है वो होती है हमारी कॉन्टूर लाइन, और नीचे वाली फिगर में जो दो लाइन है उनके बीच में जो गैप रही है उसे हम कहेंगे हॉरिजॉन्टल इक्विवेलेंट। जबकि ऊपर वाली फिगर में आप देखो तो मैं सबसे पहले एकदम बॉटम वाले पॉइंट पे मैं गोल घुमा था, फिर मैं कुछ हाइट पे जाके वापस से गोल घुमा था, और हाइट पे गया और गोल घुमा। तो ये जो दो हाइट का मैं जो डिफरेंस लेता हूँ उस डिफरेंस को हम कहेंगे कॉन्टूर इंटरनल। ठीक है, तो दो हमने वर्ड देखे, एक है हॉरिजॉन्टल इक्विवेलेंट और दूसरा है कॉन्टूर इंटरनल। अब मान लो कि इसी हील जितना मैं सेम डिप्रेशन भी बना दूं और उसको अगर मैं कॉन्टूर लाइन के थ्रू ड्रॉ करूं तो भी सेम कॉन्टूर लाइंस बनेगी। तो मुझे पता कैसे लगेगा कि ये हील है या डिप्रेशन है? तो उसके लिए जो यहाँ पर नंबर लिखे हुए आप नीचे की फिगर में देखो 7400 7300, उस नंबर के थ्रू मुझे पता लगेगा कि ये हील है या डिप्रेशन है। तो अगर अंदर वाला नंबर एकदम बड़ा है जैसे कि 7400, फिर बाहर जाओ तो धीरे धीरे वो नंबर कम होता है और एकदम एंड पे आप देखो तो 6700 बन रहा है। तो अगर अंदर वाला नंबर एकदम बड़ा है, सबसे बड़ा है, तो ये हील होगी। और अगर वो एकदम कम है नंबर, मान लो कि यही नंबर उल्टे लिखे हुए हैं, तो इसका मतलब क्या हुआ कि ये डिप्रेशन में है। ठीक है, अब यहाँ पर अगर आप देखो नीचे वाली फिगर में आप लेफ्ट साइड देखो तो कॉन्टूर लाइन हमें थोड़ी नजदीक नजदीक दिख रही है, जबकि राइट साइड देखो तो वो कॉन्टूर लाइन काफी दूर दूर है। तो जब कॉन्टूर लाइन ये दूर दूर है तो ऊपर की फिगर के साथ आप कंपेयर करोगे तो पता लगेगा कि वो जो स्लोप है वो काफी कम है। जबकि जब कॉन्टूर लाइन एकदम नजदीक नजदीक होती है तो जो स्लोप है वो काफी ज्यादा रहता है। तो यहाँ पर हमें कॉन्टूर लाइन के साथ पता भी लगता है कि भाई स्लोप ज्यादा है, कम है, हील है या डिप्रेशन है, वो सारी चीजें हमें पता लगती है। और कॉन्टूर लाइन कभी भी एक दूसरे के साथ इंटरसेक्ट नहीं करती है, वो इंटरसेक्ट एक ही केस में करती है, होती है ओवरहैंगिंग क्लिप, जो आप आगे चल के देखोगे। और अब हम थोड़ा सा QGIS के बारे में जानते हैं, क्योंकि अब हमारा जो कॉन्टूर है वो आपको QGIS के थ्रू एक्सप्लेन हम करेंगे। तो QGIS का जो फुल फॉर्म होता है वो होता है क्वांटम जियोग्राफिक इंफॉर्मेशन सिस्टम। और ऑलरेडी आपने इसके बारे में काफी ज्यादा थियोरी देख ली है, लेकिन यहाँ पर आप उसके बारे में एप्लीकेशन सीखोगे प्रैक्टिकली। तो उसके थ्रू हम क्या कर सकते हैं, तो भाई जो चीज मैंने अभी आपको समझाई वो आप रियल लाइफ में किसी भी पोर्शन को लेके देख सकते हो कि यार यहाँ पर कॉन्टूर लाइन कैसी कैसी बनेगी। तो हम उस चीज को देखेंगे, उसमें कुछ एडिट करेंगे और फिर हम उस चीज को एनालिसिस करेंगे। तो ये QGIS का जो अभी उपयोग है वो मेरी टीम आगे आपको समझाएगी प्रैक्टिकली कि भाई ये एक्चुअल में वर्क कैसे करता है।
Now Purva will explain you step by step process of making contour lines using some screenshots that were taken during the preparation of contour lines.
So first thing first, to make the contour of any place, first we need to collect the points, that is extracting the points. We can do this with the help of the Google Earth Pro that you can see over here to extract the location of the points. Now, the next step is to extract the location and to trace the path of the point. As you can see in the slide, we have traced the path of the point. Now we need to make the points saved in our computer. So as now go to GPS visualizer, because we are doing this step so as to get the three most important things, that is longitude, latitude and altitude. After GPS visualizer, we have saved our file in the computer. Go to QGIS. We have used QGIS 3.16 so as to make the contour. Explaining briefly, there are majorly 4 steps involved during the process. The first is to pass the point on the point that we chose in the Google Earth Pro. Here you can see we have obtained the layer of the path of the location that we choose. The next step is we need to do tin interpolation. As you can see, we have interpolated the points. The very next step is to do clip. This is the output of what we did in interpolation. The next step is we need to do clipping by raster extend. If you see there's an option called raster, go to clipping by raster extend. The next is we need to use the settings and do clipping by raster extend. Go to properties and save the spectral lines, because this is the step is just to differentiate the location of the point. So the color will show the different types of altitudes. Next is we need to make the contour. After clipping, we need to make the contour. So while contouring, we will extract all the points and make the contour of the point. And the very last step is, this is the final contour of the required points. So the fourth step involved is the point, second is interpolation, third is clipping, and fourth is contour.
Now I will request Dev to present you a short video tutorial of contour lines for your more clarity.
Okay, so here is a video tutorial for your better understanding. So as Purva said, we go on Google Earth Pro and we choose a location. Here I have chosen Mount Everest as a part of different terrain. So now I go to the path tracing tool, and what I'll be doing here is I'll be making a grid-like structure with many dots on the lines. So when I'm doing this, I'm basically marking the entire area of Mount Everest with many small dots. So as you can see here, I'll be covering the entire area, and all these small dots are basically latitude and longitudes of the particular point on the earth. I will be extracting this file as an extension of .kml, as you can see, and I'll be saving this file on my desktop. Now I'll go to GPS visualizer, and what this website will do is it will help me get the accurate altitude of the points which I marked on the Google Earth Pro. So I'll go to the I'll go to the option of look up elevations, and I'll be looking up all the elevations of exact latitude and longitude on the file that I had extracted earlier. Now I want this file as a text file which will be separating all these values in 3 different columns: latitude, longitude and the elevations, as you'll see further. So as you saw, all the points are differentiated and written in the column wise manner, which is easy for the software to read it. So now once I've downloaded the software, I'll go to the QGIS software and I'll make the proper layer of all those dots. But the difference between the dots on Google Earth and the dots on QGIS software is that these dots will have the value of their altitude. So as you see, I am adding a layer of delimited text layer on this new project I'm making, and as you'll see, all these points will be exactly marked on the uh, layer. So now I'll be going to interpolation. What interpolation basically means is it is a mathematical tool which will use its applications of mathematical tools to get more data. So you can see that the entire area is not covered with dots. But when I'll be interpolating the data, the entirety of area will be covered in dots. So it will be using interpolation. And what tin means, tin is triangulation. It is basically triangulation, and TIN stands for triangular irregular networks. So as you see, all these dots are not regular, but they will be it will be using triangulation method which we learned in civil engineering to get all the perfectly accurate altitudes of each and every points. So let it complete, let the process will complete, and you will see the output. Now what you will be seeing here is a very vivid pictorial layer of color, monotonous black and gray color, which you won't be able to recognize or able to read it. But as we will go to and go in the further settings, you will be able to see how it changes. So when I run this algorithm, you will see how it turns out. So now, as it is done, you will be able to see gray color, gray and white picture, which is not at all readable. So when I'll be clipping this entire pictorial format, what clipping means is you can see the irregular boundaries of the entire figure, which will be very much smoother now. So now you can see the entire picture better. So I'll be changing it to spectral format so that the different colors are very clearly seen. And when you will be able to see the clear colors, you will be able to differentiate between the different altitude of the terrain. So the lighter the terrain, lighter the color, the higher the altitude, and the darker the terrain, the lower the altitude. That is what the difference in color stands for. So as you can see, the terrain is much more vivid and we can clearly see the difference. Now I'll be turning the entire layer into a contour line, and I'll be increasing the difference in the contour lines by 20 meters. So as you can see, the contour lines are extracted now, and I'll be turning the color to black so that it is easily viewable for us. And I'll be adding the altitude to all the contour lines for our better understanding. So this is a contour for hills. So you will be clearly seeing the difference in altitude very steeply increasing. So as you can see here, the difference between two contour lines is very less, which means the slope is very steep. And at points where the terrain is basically flatter than the other parts, you will see the difference in two contour lines to be very far away. So the difference between two contour lines is basically 20 meters. So you can see the difference in the altitude and the rate at which the altitude is rising. So what you are able to see here is the altitude of that contour of Mount Everest, which is very irregular and increasing at a very great extent.
Now we will show you different contours for different types of terrain. First is India, that will be explained by Shubham.
So as Dev explained in the video how to trace the path, similarly we have traced the path of India map on Google Earth. As you can see, there are the contours of different terrains like mountains, ranges, plateaus, etc. You can see at some place contour lines are close to each other. At some places it intersect and also form concentric circles. Now the question is, how would you find that the part is a hill or a cliff on a given counter map? So in the second image, you can see there are concentric circles forms which depicts hills, and here is the zoomed out picture of Gujarat. So here you can see the Saputara hill of Gujarat, which is formed in a concentric circle. Now, if contour lines intersect each other, it depicts of overhanging cliffs, which will be explained further.
Now the second one is hills, which will be explained by Dev.
So as I had explained earlier, hills are basically terrains with increasing altitude at different points. So you can see at many places the terrain is flatter, and at many places the contour lines are very close, which suggests that the terrain is increasing at a very great extent. So there are concentric circles with many rings inside it, which are very close together and have different altitude but increasing. The same will be obtained if it is depth, which will be explained to you further.
Now the third one is cliff. So in the first picture, you can clearly see that the contour of a cliff is made by me. And in the second picture, there is one property of a cliff, overhanging cliff, that in overhanging cliff, the contour lines started to get intersect to each other. So in the second picture, you can clearly see that I have mentioned with red portion. So at that part, the contour lines are intersecting to each other. So it is a property of an overhanging cliff. Now the last one is explained by Purva, that is Grand Canyon.
So further, as it is explained, that when the lines are far apart, the contour it shows the gentler slope, and when they are closer to each other, it shows steeper slope. So it either means there is a hill or there is a valley. So if the concentric circles are present, and if you see that the elevation is decreasing, it means there is a valley present. And over here also you can see that at the topmost portion there are some concentric circles, and the number is decreasing when we go inside it. So it means the depth is present.
Our group is thankful to Professor Dhaval sir for providing us with this opportunity to learn and understand the Q-GIS software and the concept of contour. It is really a wonderful experience to be a part of this project. Thank you, sir.